Okay, welcome to the parallel and series circuit of your physics syllabus. For those of you in SPM, this is once again in chapter 2 of form 5, and for those of you in IGCSE, it's chapter 4. Okay, so basically IGCSE just groups all the electrical related topics and into one chapter, whereas SPM breaks it into 3 chapters. Okay, so this part of the chapter basically has you must understand how you must, or rather you must know how to add the different resistance. Remember there are two types of circuit: parallel and series circuit. So just a reminder, for series circuit, the formula, the total resistance is just R1 plus R2 plus R3, and you just keep adding them on and on and on to Rn, right, or to the end of your series. And for parallel circuit, okay, this is parallel. The formula is just 1 over R1. Okay, oh sorry, this is, let me rewrite this neater. 1 over RT, okay, inverse of RT equals to the inverse of your resistance, plus 1 plus R2, and so on so forth. Okay, in case this looks familiar, it's because this is like the spring. How you calculate, for those of you taking SPM, you need to actually calculate the spring constant in series and parallel. Just remember what I told you in class, they are opposite of each other. Okay, a spring in series, the formula is looks like the parallel circuit like this, and a spring in parallel looks like the series for electrical circuit. They are opposite of each other. Just remember that. Okay, the formula is the same, but that's opposite of each other. So let's take a look at our first question. Okay, let's take a look at this question here, A. So first of all, we need to determine, the question says to determine what is the effective resistance, that means the total resistance. First of all, we need to determine whether this is a P parallel circuit or a series circuit. So remember in class I told you, okay, if you're not sure, if you can't see, yeah, I can see very clearly. But if you can't see, just trace your finger from the starting point, and if you look at this thing here, follow, trace along, the current is flowing through all the resistors. Is there a diverging part? Remember, current is like a water flowing, so it's like river. So do you see the river branching off into different sections? No, there's no branch. So in this case, the river only goes from one resistor to another resistor to another resistor. Okay, there's no branching off, so this is a series. Okay, this is a series. All right, series circuit. Okay, so we're going to use this formula here. Since this is series, we're going to use this formula here, and I'm going to put, so for A, RT equals to, this is R1, this is R2, this is R3. So 12 plus 25 plus 13. 12 plus 25 plus 13, and what do you get? You get 12 plus 25 plus 13, and you get 50 ohms. Alright, so let's try C now. If you can do C, you can do B by yourself. C, again, the river starts from here, okay, but when I come here, the river has to split into 3 branches, okay, then they come back together and form one single branch. So in this case, this is, since remember in class I told you when the river splits, right, when the water has a split, that means the current going through all 3 resistors, R1, R2, R3, might not be the same because they might flow at different speeds and different rate, okay, depending on resistance. Then in that case, this is a parallel circuit. All right, this is a parallel circuit. So what I'm going to do is I'm going to write out the equation: 1 over RT, okay, 1 over 12 plus 1 over 8 plus 1 over 24. Okay, so take out your calculator. Okay, if you recall the shortcut I taught you in class, you can use that as well. Okay, if you know the shortcut. If not, you can just, if you forgot the shortcut, you can just use the long method of plugging in. 12 inverse, 8 inverse, 24 inverse, and you get 4 ohms. Alright, so you realize something, in series, when you put them in series, your resistance actually goes up. So in parallel, when you put them in parallel, your total resistance is actually lower than if you were to use just an individual, say 24. Okay, just some extra pointers. Let's take a look at another question. Let's try question 4. Okay, the question gives you a parallel circuit. Okay, why is parallel? Again, the current, this is positive, this is negative. Current comes from here. When it reaches this point here, this is a significant point. it actually breaks off into the right hand side, then goes down, then breaks off again. So this is basically a parallel circuit, right? So and then yeah, all three of them merges back here again, right? This is the part where it starts breaking off. Okay, so calculate the readings of ammeter A1, A2, A3. Remember, ammeter is always put in series to the branch. Okay, whereas a voltmeter, like this question here, is always put parallel to the circuit. So the question wants you to calculate the readings A1, A2, A3. So A1, the current A1 here is the total current going into the circuit. Okay, basically this is the part of the river before it splits off at this branch here. So that means the current here is the highest of all the circuit. What I'm going to do is I'm going to redraw this circuit. When I do this kind of question, it's easier to redraw. I'm going to redraw this circuit as one resistor. Okay, so the reason why I draw this as one resistor is because I want to find what is the total current needed be provided by this battery, and in order to do that, I need to combine all three of this resistor here as one. Okay, so once again, RT 1 over RT equals to 1 over 9 plus 1 over 30 plus 1 over 45. Okay, 9 inverse plus 30 inverse plus 45 inverse, and you get 6 ohms. So that's the reason why we learn how to actually this is 6 ohms here. This is the reason why we learn why we actually need to combine resistance, so that we can know the total or effective resistance in the circuit. Right, if we are given a complicated circuit like this, we can simplify it to find the total current. Right, in this case, since this is 12 volts and the total circuit and the total resistance, the current 6 ohms, the current A1, or the total current coming out of the battery, must be using Ohm's law. Right, so everything starts to tie together now. 12 divided by 6, and you get my handwriting is big. 12 divided by 6, and you get sorry, this is wrong. I wrote it wrongly. You get 12 divided by 6, you get V over I equals to R. Okay, I, V over R, 12 divided by 6, alright, okay, and you get 2 amperes. So the current coming out of the battery is 2 amperes. Okay, so what is the current going into each of this then? Okay, if the current is 2 amperes here, the current going into the first one, okay, how are we going to do this? How are we going to solve this? So it's very simple. Since we know that the voltage across each branch must be 12 ohms. Remember, voltage in a parallel circuit is always the same. Each of this, the voltage across the 9 ohms, the 30 ohms, and the 45 ohms are all 12 volts. So using Ohm's law again, it's very simple. Just take V over R equals to I. Let's do for A2 equals to A2. Okay, and I will get 12 divided by 9. What do I get? 12 divided by 9, you get 1.33 amps. Okay, let's do it for A3 as well. Okay, you can try for A3 as well. Plug into your calculator. Let's highlight this answer here. A3 would you get, if you do it using Ohm's law again, just 12 divided by 45, and you get 0.266 amps. Okay, let's just try for this one, even though they didn't request. I'm just going to call this A4. Let's just find for A4. Again, just take 12 divided by 30. You get A4 equals to 0.4 amperes. Okay, now I want you all, just for fun, it's not requested in the question, add all of them together. So it's the current A1, the current A2, don't add A1, A2 plus A3 plus A4. What do you get? Okay, you get 1.33 plus 0.266 plus 0.4, and you get 1.996 or amperes, or equals to 2 amperes. So can you see that the current here, 2 amperes here, has actually been broken down into each of this smaller current into smaller currents, and if you add them all get back together, you get back 2 amperes here. Yeah, this is probably my messiest worksheet yet.